Hello out there in math e-learning land. Today we're moving on from rational expressions and jumping into the world of solving rational equations. This is going to be our last topic before our Unit 9 test. So we will do a couple days of notes on this, a little homework for practice, and I will get you your quizzes and some feedback, and then we will begin our review for the test. All right, let's get started right away then. All right, so this is it. I can solve rational equations. Finding the LCD, and of course, when we say LCD, you guys should know what I mean by now, but let's go ahead and fill in these blanks anyway. Least common denominator, because this is what it's all about. This is what it's been all about with adding and subtracting, and this is what it's all about with solving equations. So here we go. Let's look at example 1. And we're starting off with something that's relatively easy. And you can tell that it's relatively easy because our first step is to define the common denominator. And if we look at these three rational expressions, we have x squared, we have x squared. I already have the same denominator. Oh, that's sweet. So what do I need to do to get this to have the same denominator? Now hopefully you're all sitting there saying, all you need to do is multiply that by x, Mr. Chelmecki. So multiply each one of those by x. That's going to get everything to have the common denominator. Now check this out. Once we get this thing to have a common denominator, this is now the right side of the equation, just like adding and subtracting like we've been doing. So we can combine those numerators and we get one expression on the right side, and we already had just one expression on the left side. Now think about this as we would solve an equation. If I want to simplify this, I want to get something out of the denominator, I can say, okay, well, it's in the denominator. All I have to do is multiply both sides by that denominator to cancel it out. So watch this. Multiply this side by x squared. Now if I multiply this side by x squared, I'm solving an equation now. I have to multiply the other side by x squared. Again, I'm solving an equation. So what happens is, boom, those cancel, boom, those cancel, and now we have no denominators. So our new equation just looks like this. Okay, now, as you get more comfortable with this, you don't even have to show me that step. Okay, really, all we need to remember is that once the denominators are same, once all denominators are the same, set numerators equal and solve. That's really all we just did. So here we got the denominators the same. I showed you the algebra about why we can do this, but then we just straight down to getting our numerators as one equation. So if you look at this stuff right up here, notice that what I have there is exactly what I have here. And as you are comfortable with that, you can go straight from this step all the way to this step. Okay? So now, depending on how simple our equation is, this could be really easy to solve. This could be a little more challenging to solve. Here we have a linear equation, so this is not very difficult at all. I'm going to subtract x from both sides. I get 2x minus 3 equals 1. And I'm going to add 3 to both sides, add 3 to both sides. I get 2x equals 4. And finally, I'm going to divide by 2. So I get x equals 2. Okay, now, notice step 4. Once we get this, we have to check for extraneous solutions. We talked about this at the beginning of the unit and said that in a rational expression, we have these things called excluded values, or things that cannot have a value there. So once we get that solution, we need to plug it back into the denominators. Plug into denominators, okay, and make sure they don't equal 0. So here, this is easy to do. Plug in 2. 2 squared is 4. Good, it's not 0. 2 squared is 4. Good, it's not 0. Plug in 2 is just 2. Good, it's not 0. So that means 2 is a legitimate solution. Let's write that in a solution set. and let's put a box around it so we know that we've checked. Okay? Let's keep going. All right, notice our next one. Remember, our goal, just like it has been, is to get a common denominator. So as we look at each one, same, same. Oh, that's awesome. So now all I need to do is get this one to be the same. What do I need to multiply this denominator by to get it to be 2n squared? Hopefully you're all saying, well, that's just 2, Mr. Chomecki. So multiply each one by 2. Okay. Now remember, once we get those denominators to be the same, 2n squared, 2n squared, 2n squared, we can take that numerator up here and just make our new equation. We don't even need to do anything with the denominator now. So here's what we get. 2 times n plus 4 equals n minus 4 plus 1. There's our new equation. How easy is that? Okay, so that's what we're trying to do. Okay, of course it can be more difficult. If the denominators are more different, we have to multiply them more things. If the numerators have more terms to them, it can make it a little bit longer. But again, the strategy or the concept is not a big deal. You just got to practice. Distribute, 2n plus 8 equals n. Negative 4 plus 1 is negative 3. And again, let's just solve. Minus n. I get n plus 8 equals negative 3. Minus 8, and I get n equals negative 11. Okay, before we stop, make sure that we check. So we're just going to check that, plug into the denominators. Do denominators equal 0. Negative 11 squared, not 0. Negative 11 squared times 2, not 0. Negative 11 squared times 2, not 0. No. And you're good. That's our check. It's that easy. Write it as a solution set. Let's put a box around our answer, and there we go. Okay. Maybe you want to pause this one, try this one on your own. I'm going to go ahead and step through it again because we don't have too many examples today. So I'll keep going. Actually, you know what? Why don't you guys go ahead and try this one on your own? Because the ones in the back are going to take us a little more time, and you can check your answer for this one. Once you get through, you should get a equals 8, and make sure, again, you remember that check step. Although that one works out really nicely. All right, pause it, try that one out if you're ready. All right, number 4. All right, we got a little bit more going on here. Denominators aren't the same on any of these. So as we look at it, again, we need our common denominator. So 10. This might help if you guys break this down. 10 is 2 times 5, right? So I can see that 10 is 2 times 5. I have 2 here. I have x plus 3. I want to put parentheses around that again so I see it as one term. Okay. So 10 as 2 times 5. I also need the x plus 3. So that's what this numerator is going to get multiplied by. Okay. 2 has the 2. I need the 5. And I need the x plus 3, so let's put that up here. 5 times x plus 3. I have the x plus 3. Okay. I need the 2 and I need the 5, which is really just 10. So there we go. Now again, we got our denominators to be the same. If you want to write that one down there so you see it or wondering why I didn't write it there. Okay, we got our denominators to be the same. So now all we care about is our numerators. So let's go ahead and simplify this a little bit. 10 times 2 is 20. And just write our new equation with numerators. 3 times 5 is 15 times x plus 3 equals 19 times x plus 3. And there's our new equation. Boom, denominators are gone. And now we can go ahead and set up this nice equation and solve. My pen skip there. Make sure you don't think that's a negative. All right, so I'm going to distribute 15, distribute 19, 20 plus 15x plus 45 equals 19x plus 19 times 3 is 7. Solve for x. All right, so let's move this guy over, minus 15x, minus 15x. I'm going to jump up here. And now I have 20 plus 45 on the right side, or on the left side is 65. 19x minus 15x is 4x, plus 57. Subtract 57 from both sides. And 65 minus 57 gives me 8 equals 4x. Divide by 4, divide by 4, and we get x equals 2. Again, we need to check in our denominators and make sure none of them result in 0. These are already constants, so they're good. So we just need to plug in here. So check. That denominator is x plus 3 or 2 plus 3. That's 5. 5 is not 0, so we are good. There's our solution, x equal 2. Feel free to pause it, watch that again, try out 1 or 2 on your homework. All right, let's go to 5 and 6, because now you see we have some quadratics, some polynomials to work with. Okay, name of the game is still common denominator. All right, so you guys know when you see these, we're going to factor and see what we get. So I'm going to start by factoring here, so I can find that common denominator. Negative 8 on the top, positive 2 on the bottom. That's going to be negative 4 times 2 gives me negative 8. Negative 4 plus 2 gives me negative 2. So I need to change that. It's going to be positive 4 and a negative 2. That's better. All right, now these guys, I want to put parentheses around them because they're good. We're leaving them as they are because those are the binomial and factored form. Don't mess with that. 2p plus 1, and then this is going to be p plus 4 and p minus 2, and then we have 2 over p plus 4. All right, now you look at this, and hopefully, like me, you're saying, well, that's convenient. Okay, I'll have some combination of these factors, so I'm not going to have to do too much work here. So let's see, I have p plus 4, p minus 2, so that means this guy needs a p minus 2, right? P minus 2. This guy needs a p plus 4. Okay, now again, denominators are the same, so we don't care about them anymore because we can cancel all them out if we're working algebraically. So in the top, p plus 4 times 1 is just p plus 4. Then this one didn't change, still 2p plus 1. But what I do, I put an equal sign here. Let's fix that. Should be a plus. Okay, and then we have plus 2 times p minus 2. All right, there's our new numerators after getting our common denominator. And now let's go ahead and solve this equation. Distribute the 2 here. Okay, p plus 4. And you guys can show as much work as you want here. Show me a couple steps at least. Show me as much as you can to make sure you don't make mistakes in your head. All right, so I'm going to simplify the whole right side of this equation now. I'm going to move up here. So on the left side, we still have p plus 4 equals, I like to simplify one side of the equation at a time. And 2p plus 2p is 4p, and then 1 minus 4 is negative 3. All right, so hopefully we all got that. Let's go ahead and add 3 to both sides. Okay, I'm going to subtract the p while I'm at it. Might as well do these two steps at the same time. 4 plus 3 is 7. 4p minus p is 3p. Divide by 3, divide by 3. Now here's the thing with these, is that there really is no easy way to check. We can take that 7/3, but to check it, we'd have to plug that into every single p here. So there's not really a quick and easy way to check. So my recommendation is if you get an answer like this, just go back and double check your work and make sure it looks good. Now as we check our denominators to make sure we don't have a 0, this is easy to check here instead of in the original. Because in factored form, if this, we know if it was a negative 4 or positive 2, it would give us a 0. But it's 7/3, so we're good. And 7/3 plus 4 is not 0. 7/3 minus 2 is not 0. So this guy is good to go. And that's our one solution. All right, so I'm going to do one more for you guys today and then let you get started on the homework. our next notes, we'll do a little bit more practice with this. Feel free to email me with any questions as you guys are working. Notice how all this layers. Okay, so if you guys have been keeping up with this might look daunting at first, but again, the strategies and skills are exactly like what we've been doing. So if you've been keeping up with it, you're probably in pretty solid shape right now. All right, so again, I need to start with the same thing by factoring. So I'm going to check and see, can I factor this guy? Can I factor this guy? Okay, so that numerator should be -10 on the top, -1 on the bottom. And our only factors of 10 are 1 and 10 and 2 and 5. So there's no way that I could get a product of -10 and a sum of -1. So this one's not factorable. So we're just going to leave it the way it is. Let's check that one in the denominator though. 15 on the top, 8 on the bottom. So factors of 15 that add up to 8. Hopefully this is jumping out to you. We get 3 and 5. All right, so here we go. This is going to end up being really similar to our last one, so check out what we get. So there's our first rational. Our second rational, again, this dude stays the same on top. You want to put parentheses around it so you're not tempted to mess with it. It's always a good idea. On the bottom here we have x plus 3 and x plus 5 once we've factored. And then that equals 3 over x plus 3. And again, put parentheses around these guys. I definitely recommend that. Then you're not thinking about things, separating things, or canceling random things out. Okay, it's going to help. And now we see x plus 3, x plus 5. There's x plus 3, there's x plus 5. So this guy needs the x plus 5. And this guy needs the x plus. And then our middle one's going to stay the same. Just be careful with this minus sign when we start simplifying. So on the top, let's just rewrite our new equation with our numerators. 2x times x plus 3 minus. And again, this is where it's a good idea to put this in parentheses, because remember, we're subtracting that whole thing, so we can think about that as a minus sign or a negative sign being distributed to that whole expression. All right, so as we distribute now and simplify, distribute. So that's going to be 2x squared plus 6x. Think about this as distributing the negative. Makes that negative, makes that positive, makes that positive. So it's going to be minus x squared plus x plus 10. Distribute 3, 3x plus 15. Okay, once we get that out of the way, this isn't too bad. But you guys can see we're going to end up with a quadratic here. Okay, don't freak out. We've been solving quadratics all year. When we see x squared, our strategy is to get all the x's on the same side. Okay, I like to keep my x squared positive, but watch as we start simplifying. 2x squared minus x squared gives me positive 1x squared. 6x plus x gives me 7x. And then we have that positive 10. And then on this side, 3x plus 15. All right, move these guys over. Keep our x squared positive. And here's our quadratic then. X squared plus 4x plus 5. Sorry, minus 5. Because that's a minus 15. So let's fix that. And now we can factor and solve. So again, once we get out of those fractions, it's just like solving any equation that we've had. So this is a quadratic. We're going to factor it, -5. If you feel so inclined, feel free to use the quadratic formula. Okay, I'm probably not going to give you things that you can't factor, but again, remember, quadratic formula works for everything. So two factors that multiply to -5 add up to +4, +5, -1, and here we go in factored form. Once we get those factors, we set them equal to 0. And we solve, and this gives us -5, and this gives us +1. Now again, we need to check these back into our original denominators, and I like to check in factored form. Check it out. Here we have a solution of x equals -5. When you plug that in, all the way up into this denominator. Right here. This is where we're going to get an issue because you plug in that negative 5 plus 5, that equals 0. It doesn't have, it can be any single one of them. If you have one denominator equal to 0, this is not a solution. So that's what we're checking for, because if we try to plug that into the function, it's not going to give us a valid solution. Okay, so we see that in one place, it's not going to work. Our next solution we check is 1. Check it up here. 1 plus 5 is 6. Good, it's not 0. 1 plus 3 is 4. Good. 1 plus 5 is 6. 1 plus 3 is 4. We're all good here with 1. So that means that x equals 1 is our only solution for this. Okay. All right, try out that homework, guys. We'll do some more with these tomorrow, and I will see you soon. Email me with any questions. We'll do another Google Meet before our test.